here we have the additions, and it's basically how to do basic arithmetic. So far we are only looking on to unsigned number, so they're all positive only. So we are not looking at any negative number. And the basic rule is that if you're adding 0 to 0, it's a 0, obviously. 0 to a 1, it's gonna be a 1. 1 to a 0, it's gonna be a 1. So far so good. 1 plus 1, it's gonna be a 0 and carry a 1. So very similar to base 10 that we have. So for example, if you have like something like 9 plus 1, you're gonna get 0, and then you would carry a 1. You drop the 1. So that was in decimal, that's what we have. Here we have only 0 and 1. And 1 plus 1 gonna be a 0, because basically it's gonna be a 1, 0, right? That is 2 in decimal. And you carry a 1 to the next one. So we see an example here. We are adding these two binary numbers. It's very straightforward. You just start from the right, same way as you would do on a decimal number. So 0 plus 1 is 1, 1 plus 1 is 0, but we are carrying a 1. And then we have 1 plus 1, again 0, carry another 1. 1 plus 1 is 0, carry a 1. 1 plus 1, 0, carry a 1. And then 1 plus zeros, it's going to be 1, and then 0, 0. So far so good. This is another example. 1 plus 0 is 1. 1 plus 1, 0, carry a 1. 2 1s, we get a 0, 1. Same thing is repeating again. Here we have 3 1s. So 2 of these, so let's say these 2, gonna be 1, 0. So this is gonna be a 0, and we carry the 1. So that 1 here is from 2 of them. And then we have 0 and 1, and that's gonna be a 1. And then we have the next one, 1 and 1. We get a 0 and carry a 1. And then just a 1 and 0. Straightforward. So let's move on. Okay, what if we are doing subtraction? So subtraction is basically again the same thing as our decimal. These are easy. 0 minus 0 is 0. 1 minus 0 is 1. 1 minus 1 is 0. There is the one that we have to borrow. So if you do 0 minus 1, we are going to get a 1. 0 minus 1, we always get a 1. And we always borrow from the next most significant, so the one to the left. The only thing here in computer when we are doing these, and we're going to talk about it, we are always borrowing from the left, even if we don't have, we kind of take it from outside, and we're going to see examples of that. But first, let's look at these. So we have these two numbers. So this is simple. 1 minus 1, we get 0, 0, 1, 0. Here we are doing 0 minus 1. So what happens when we borrow? So we already said that this is going to be a 1. But I'm going to show you why, actually. So when we get from the next one, so this is going to get 0. That is easy. So this 1 comes 0. And when we take this 1 and bring it here, we are actually getting 2 1s. Why is that? Because when would we get a 1 here? If you had 2 1s, like let's say here, if you had 2 1s and you're adding them, you get a 0 here and you get 1 on the next one, right? So if you are doing this the opposite way, sorry about this, but if you're doing this the opposite way, you're gonna get 2 1s back. Another way of looking at it, is that this 1 is basically 2 times of this value. So the value of this 1 here is 2 times of the value of the lower significant one. So again, if you look at the, let me try to remove this. So if you are looking at the number, and I'm gonna say it in decimal. So we have 1 and 1. That's gonna be 0, 1, and then we drop the 1. So we get 1, 0. So what is 1, 0 in, so this is in binary. But what is the value of this in decimal? It's gonna be 2 to the power of 1. So it's gonna be 2. So actually the value of this is 2 in decimal. So decimal. And this is the same thing. So this one gonna be 2 ones when you take it to a lower significant. If you take 2 ones to the upper one, it's gonna be 1 only. So let's look at this. So after we got this one, we have 2 ones, and then we are minusing 1. So we are getting 1 remaining, and then this is gonna be 0. This is another example. I see there is more going on. So let's see. Look, 1 minus 0 is 1. 1 minus 1 is 0. So here we have 0, and we are minusing 1. So we cannot do this. So we're gonna go to the next one, and we see that this is 0 also. So we go to the next one. So this becomes 0, and then I think this is from later. When this becomes 0, here we get 2 ones, but then we want to borrow 1 to the next one, so we get rid of this, and then we get 2 ones here. So this didn't happen yet. And then 1, 1 minus 0. So we get these 2 goes together. We have only 1, 1 here. Here we have 1, no, nothing, zeros. We get 1. Here, this one we already gave, so it's 0 at this point. And we cross this one, this becomes 0, and we have 2 ones here. And that is 2 ones minus 1, it's gonna be 1. And then the rest are 0. So that's basically 2 sample of subtraction. If it's not clear, I would record a different video without this pre-existing one and change the video. Let me know if this is not clear. Here we are looking at the hexadecimal numbers addition and unsigned only. So there is the positive only. So it's very similar to what we have done with the binary or what we have done with the decimal. The only thing could be tricky is the carry. So let's first look at something in decimal that you're familiar with. So for example, if you're adding number 8 plus 4, and that's decimal, it's gonna be 12, right? 8 plus 4 is gonna be 12. But how do we write it here? We actually, after adding this 12, we are minusing that by the base, because that what is can like that is what can go here, right? That 2 can go here when we minus. So we have the value of the base, which is the next most significant one, and we deduct that from this sum. So 8 plus 4 is 12. We deduct the base, which is the value of the next most significant one, because we're going to get 1 here. So if I want to explain it in a different way, we know that I cannot put 12 here, right? So 8 plus 4, I cannot put the whole 12 in this position or in this place. So how do we fix this? We have to take some of this to the next position, basically the carry. But then how do you know how much to take? That's always gonna be your base. So in base 10, we are subtracting 10 from this number and we get 2. So 2 gonna end up here, and that 1, it's gonna be on the next, on the more significant one, because that's always a value. So in base 16, it's gonna be the exact same thing. So here we have a plus b. So if you are doing a plus b, so that is gonna be a is 10, b is 11. So if you add this, you're gonna get 21. So we cannot put 21 here. We don't have a digit for it, right? So how do we do that? We deduct the base, because that is what the carry will be. So we know we're gonna get a 1 here for sure, right? Because we have a carry, we're gonna get 1. But what is the value of this 1 that we are taking to the next one? The value of this comparing to this is gonna be 16. So 1 or 21, that's in decimal, minus 16, we're gonna get 5. So we're gonna get the 5 here and 1. So that's 1 5 in hex. And do I have it here? Actually, I don't have it here. So if I convert this one back, I just want to show you that we are getting that 21 back. So this is in base 16, 16, and then this is index 0, index 1. So this is gonna be 1 times 16 to the power of 1 plus 5 times 16 to the power of 0, which is 1. So look, it's 16 plus 5. So that's 21. So it's the same thing. It's basically back and forth. So that's the only tricky thing. Whenever you have a carry, just minus your base. And that's the value that you're going to put here. And on the next one, you're always going to be 1, because like 16 going to be 1 on the next, on the more significant one. So here we have examples. We are adding these two numbers, 4a6 and 1b3. These are straightforward. 6 plus 3 is 9. A plus b, well, actually, this is the example that we have here. So that's going to be this 5, and then we get 1, and then 4, 5, 6. So 6, 5, 9. That's going to be in hex. And I would put this one also. And then here we have another example. The zeros are basically, we just drop them. C plus 1 is D, B plus 1 is C, A plus 1 is B. So nothing out of the ordinary. So let's continue to the subtraction. So the rules are the same. The only tricky part is when we are borrowing, and whenever we are borrowing, it's gonna be 16. So in decimal, when we are borrowing, we go borrowing 10. In binary, we did borrow 2, and in this is 16. So it's always like the base. So let's look at the example. We have 4a6 minus 1b3. So 6 minus 3, 3. A minus b, this is smaller. So a is 10 and b is 11. So let me actually write these. So we do have here, okay. So we have A, B, C, D, E, and F. 10, 12. Okay. Okay. So you see that A is 10 and B is 11. So we cannot actually subtract this. We have to borrow. So we are borrowing from the next one. This 4 become 3, and we get 16 here. So now we have 10 and 16 minus 11. So we have basically, this is 26 minus 11, which is gonna be 15. So 6 minus 1 is 5, 2 minus 1 is 1, so 15. What is 15 in hex is F, so we get F. And then 3 minus 1 is 2. So not so bad. Here we have another one. So from the beginning, we have 0 minus f, which we cannot do. And we have to start borrowing. So this will become, like all of these are 0, so we cannot do. So from here, we have c. This becomes a b. And we get 16 here. And then because we want to take it all the way to the first one, so this 16 has become 15, and then we get this 16, and then again this 16 has become 15, and we have this 16 here. And now we can do the subtraction. So 16 minus f, so f was 15, so that's gonna be 1. And then we have 15 minus e, which is 14. So again 15 minus 14, 1. 15 minus d, so 15 minus 13, that's 2. Then we have b minus 1, which is 11 minus 1, that is 10. So we get an a. And then b minus 1, same thing, we get an a. A, which is 10 minus 1, that is a 9.